Okay, so let's take a look at a practical example of using the sort of the maths that we've been discussing up till now, and sort of applying it to an effect. So here I have three different examples of how we can sort of apply an electricity effect, right? So we're going to look at these each in turn and see how these apply some of the principles we've discussed so far. So let's dive in to the first one, right? So here we have just a sort of an orb, and we've got some electricity moving around within that. Okay, so let's have a look at how we've built this. So very simple setup. Okay, I'm just importing my geometry. I'm sort of isolating the center because I have a center orb here and then the outer edge, and this is where I'm having the electricity jump between. So obviously I need my glass and then the center actual sphere. And what we're really doing is scattering points onto the inside, on the inner sphere, and then I am just setting an ID here. ID is really important for like when you're working with points, because here when we ray these particles onto the outside and then merge them, we now have both sets, but each of these points on the inside has a corresponding point on the outside, right? And how do we know which one corresponds with one another? Well, because of that ID. So this ID here is vital to this. You'll see here when they're merged, if we look at ID, there are 2 zeros, 2 1s, 2 2s. So those are the ones that need to be joined with the add. So when we have add, and under polygons by group, I just choose by attribute and choose ID. It now joins them, joins 0 with 0 and 1 with 1. Okay. So this is how I'm essentially creating these lines. And because I've scattered on the inside, but then I'm raying to the outside, it should sort of be the shortest distance. So, which is kind of what electricity generally does, is it's going to jump to the sort of the path of least resistance. So it generally is going to go to the closest point on the surface. And then I'm resampling, because obviously we want a lot more geometry than just the one polygon, 2 points. We need some more because we want to add some noise to this. And I also have my curve view attributes switched on, which is essentially just a 0 to 1 along this line. So I've renamed it grad because I prefer to just use this as grad. I always call it grad, but by default I think it's called curve view. Right, so this is all just the sort of the basic setup, but inside of here is where all of the maths is happening. Okay, so obviously we need to apply some noise to this to make it look like electricity. So if I dive inside, you'll see that we have a turbulent noise, which I have set to sparse convolution noise. And, just found the right kind of settings that gives me the look that I'm after. But the real trick here, and this is where the maths comes in, is we're using the sort of techniques I was discussing with floor, particularly when I was saying that we would multiply by the inverse of the step that we want and then floor it, right? So I'm taking frame number here, and then I'm multiplying it, but not multiplying it up, but actually multiplying it down, okay? And the smaller I make this number and then floor it, what's going to happen is I'm getting more frames have the same number, on our step, before it then suddenly jumps up to another number and then they all have the same, okay? The smaller this value is, essentially the wider that step is. So I'm binding the result of this out to a seed value. I'm not actually using the seed value, I've just got it here so you can see what is happening, okay? So as I drag through the timeline, you'll see here that the seed changes, okay? So as I move forward in frames, it's still 0, and then suddenly it jumps to 1. Okay, so on frame 12, it goes to 1. And now you'll see it's still 1 for several frames until eventually on frame 23, it becomes 2. Okay, so we essentially have 11 frames of each step, but starting with frame 1. Okay, so 1 to 12, and then 12 to 23, and so on. Okay, and so you can obviously adjust the size of that step, but this is what's happening, what's causing the kind of sudden jump or change in this noise, right? Because I'm using that to drive the offset of my turbulence. Okay. Now I'll discuss what's happening here just now, but essentially this is causing it. If we take this one out, so I'm just going to unplug this one, you'll see what happens here with the noise is it just readjusts itself every couple of frames. Okay. So when we go from, from 0 to, from 1 to 11, it's the same. And then when we jump to 12, you'll see that everything shifts. And then it stays the same for a while. Obviously, there are some things getting switched on and off. I'll explain that just now. But then suddenly everything changes again. Okay. So this is one of the aspects that makes electricity kind of look, like we'd expect it to look, is it suddenly reseeding itself, or readjusting the kind of the noise, right? But in these kind of plasma balls, you also see it does kind of warp and move a little bit as well. So that's what I've got here, is I'm just using my frame number but multiplied really small to create a very small sort of offset. So as it's moving, you'll see that not only does it jump and reseed, but it also seems to wiggle a little bit. Okay. Now, let's jump up again and go back to our scatter though, and you'll see that in the scatter, I'm also doing the same thing as we were doing inside with the noise. I am taking my frame number, I'm multiplying it down, and to make it more visually apparent to myself, instead of just multiplying by 0.23 whatever, I'm inverting. Okay, we're using inverse, which we discussed before, where I'm saying 1 divided by and then the number, because now this number is accessible to me. When I type 7 here, it means that every 7 frames this is going to change. Okay, so now I can just go and say very specifically, I want this to change every 15 frames, and I don't have to try and mathematically work out what the inverse of 15 is. We just have 1 divided by, and then I go and adjust this number. And if you really wanted to, you could expose that as a parameter. You could just link it to a spare parameter on your sheet, and then just adjust that integer, and then it tells you exactly how many frames it'll go before it readjusts itself. Now all I'm doing is I'm multiplying by the inverse of the size of the step, flooring it, and then I'm taking that number, whatever that number is, and using that as the seed for my random function, which I'm fitting to 20 and 30. So what that means essentially is every 7 frames, it's going to come up with a new random number between 20 and 30, and that will be the total count. So right now, it's scattering 25 points. But over here, as soon as we cross that threshold, it's scattering 27, then 23, then 28, and so on. You'll see it's always between 20 and 30, and it readjusts itself constantly. Now the same thing is happening here with our global seed. Okay, same thing, taking frame number multiplied by the inverse of a number of frames. So we've got it here in our seed, our total count, and our noise. But the trick here to kind of make it seem very erratic, like we would want electricity to be, kind of it keeps kind of twitching and readjusting itself, is the fact that the amount that I'm feeding in is different. Okay, here I haven't done the inverse. I've actually literally just multiplied by a smaller number. But if you wanted it to be a very specific number of frames, you could just do that. We would just multiply by 1 divided by, and then whatever number we want to. But this number here is adjusting every 11 frames. The scatter is adjusting the number of points every 7 frames, and the seed every 20 frames. And so because those numbers are all different, there's different things are happening. Sometimes in the middle of a noise step, you'll see that extra sort of whatever you want to call these sort of arcs, get added or sometimes taken away. Like sometimes they'll readjust because the seed, that the number of the total count of the points being scattered changes on that frame, but it hasn't quite reseeded the noise yet. And so you can kind of see things getting switched on and off and adjustments happening. And so when we look at that all together, it kind of adds up to this very kind of erratic electricity look. Okay. And then all I'm doing else, like inside of here as well, is I'm just multiplying by that gradient that we had. So 0 to 1, I'm just putting it through a ramp. And the reason for this is just because obviously when the electricity arcs from the sphere to the inner sphere to the outer sphere, we want them to touch, and the noise is obviously going to move those points. So we want to make sure that the noise has no effect at the root and the tip of that arc, but in the middle it is allowed to arc. Okay, so that's pretty much all that's happening inside of this noise. And then all I'm doing is kind of applying that same sort of system, but just to some extra sort of smaller little arcs that come off of the main beam, right? So I'm just carving, so I'm essentially just cutting away to just the tips of these arcs to a certain amount, and then scattering points on those tips, and then doing the same thing really. I'm basically raying it onto the surface. Okay, I'm here sort of offsetting by a random kind of noise just so that they are kind of aiming in slightly different directions, but then I'm raying it onto that outer surface and rejoining it. But because I've created an ID, like we discussed before, we can join them with a line. Okay, so essentially just scattered a bunch of points on our original arcs here, and then I'm raying them onto the surface, and then applying the same kind of noise, right? Also modulated by the gradient so that it still touches the original arc and touches the sphere correctly, but then the noise changes of the shape in the middle, right? And inside of here, same thing's happening, okay? We've got this seed, and you'll see this is different. So this will readjust itself more frequently than the other arcs, right? And then just merging that all together and giving it a color that seems just, a little bit more lightning-y. Okay, and that's pretty much it. So very, very simple setup, but you'll see how we can use that rounding and then multiplying and sort of inverse in order to kind of create these erratic changes. Okay. Now, moving on, we have a very similar setup here. The principles of what we've just discussed about the lightning and how it readjusts itself every couple of frames is applied across all of these electricity experiments here. But the one additional step that's happening in this one in the middle is you'll see that it switches itself off and on. So it kind of arcs and then stops. Arcs for a couple of frames and then stops. Okay. So let's see how we're achieving that. So in here, all I've done is I've taken my two spheres that I'm wanting to arc between, and I'm splitting them up. So I have the one sphere and the other sphere. Now here I scatter points onto the sphere, so you'll see I'm scattering onto there, but I don't want arcs going through the sphere. I want them to kind of go the shortest distance, so from the inner side of this sphere, kind of from the hemisphere somewhere, to the other hemisphere on the other sphere. So in order to not have stuff not going through, what I'm doing is I'm actually, in a wrangle, I'm setting the X value to 0. So after scattering, I'm moving it into the dead center. Okay, this is because I'm working at the origin, so I know that the center is here, halfway between these two spheres. And so after scattering, but then adjusting the X to 0, and then here I am also creating an ID, which we obviously know why we need that. I'm then raying it back onto the sphere. So it ends up, because it's taking the minimum distance onto the sphere, the point that was at the back here, scattered onto the back, was moved into the center and then rayed onto the sphere, so it will be somewhere in the middle here. Okay. And I do the exact same thing on both sides with the same number of points. Okay, so you'll see here I am still randomly selecting how many points I'm creating and readjusting it every 7 frames. But on this second scatter, I'm referencing the same number of points because I need exactly the same number of points, right? But then with the seed, doing the same thing, except on this side, the seed has its own additional random value added to it, so that left and right are not exactly aligned, okay? And then exactly the same process, we ray it onto there. So what the result of this is that we have exactly the same number of points, so in this case 4 points on the left and 4 points on the right, that are sort of on the inner edge of these two spheres, but they are kind of in a slightly random different position from one another. And then okay, I'll show you what's happening inside of there, the maths of that just now. But ultimately what's happening is we're drawing those lines between, okay, and because they have matching IDs, because we created them here, and there's only 4 points, so their IDs will be 0 to 3. And on this side, their IDs will be 0 to 3. When we add them together, then we get these straight lines, and then we do our exact same setup that we saw before. We've got our lightning, we also create our extra arcs, and we merge it all together, okay? But the extra step that's happening here is this. So what we're doing is we're essentially deleting these points on certain frames. And this is where we can use our modulus function. Okay, so we spoke about modulus and how it essentially, when we set a certain modulus number, right, so the divisor, it's going to loop. So from, and in fact, you'll see I have created a foo attribute over here, which is essentially just showing what this number is resulting in, okay? For any of you who don't know, foo is kind of used as like a placeholder, like temporary attribute. So when you see foo, you know that it's not something that's being used. It's just a way of visualizing or testing something. So what we have on frame 1, because we're using frame number in our modulus, and we're setting modulus to 50, what that's going to result in, if we look at our foo, on frame 1, it's 1. On frame 2, it's 2. Frame 3, it's 3, and so on, right? And it keeps being true. Sorry, I'm just going to disable this delete so we can see it all the way. So it keeps being true all the way, and it keeps going higher and higher, and then we get, so on frame 47, foo is 47. Frame 48, it's 48. 49 is 49. And then what happens as soon as we hit 50, because 50 divided by 50 is 0, 50 divided by 50 is 1, but the remainder is 0. So in other words, the modulus is 0. Okay, so it jumps back to 0. Now, as we keep climbing on frame 54, then the modulus value foo is 4. Because what we're saying essentially is, what is 54 divided by 50? It is 1 with a remainder of 4. So that means our modulus is 4. Okay, so we are looping every 50 frames. You'll see this keeps climbing and then loops back. Keeps climbing, loops back, right? So every 50 frames, it loops. Then what we're doing is we're comparing. Okay, so I use a compare to essentially say, if this value, this foo value that we have, is greater than 20, because we know it keeps going from 0 to 50 and then 0 to 50 and keeps going like that. So as long as it's greater than 20, then we're removing all of the points. Okay, so I've just got an if block here and I'm just feeding in the point number. So I'm essentially saying delete all the points when this frame number modulus to 50 is greater than 20. What that means then for us is that for the first 20 frames, we will have points. And then after 20, they get deleted for 30 frames, because it's still calculating the modulus. It still knows that, you know, what that value is. It's just that that value is greater than 20, so it's deleting the points. And then when we cross over the threshold again and it loops back to 0, our points come back. So now what this essentially means is we say the cycle is 50 frames long, but 20 of that we have points, and 30 of those frames we do not have points. And then that's what's happening here. So you'll see we arc for 20 frames, then switch off for 30, on for 20, off for 30, and so on. And you can obviously decide, you can choose those exact numbers. You could even animate those numbers up and down, although you will then have things suddenly sort of appearing or not, but you could have those numbers go up and down. So all we're doing, same system, but we're using modulus as a way of randomly kind of switching things off and on. Okay. And then let's move on to our final example. Now again, very similar principles applied here, so we won't go in depth into how the lightning is being created. But what happens when we have lightning arcing very close to other objects, particularly along a floor, okay, along the ground? So we want these very large sweeping arcs, okay, which looks kind of nice, looks very, lightning-y. But the problem with applying a noise like this is it tends to dip directly into the ground, okay? So we'll see here, if I go in, well, let me just quickly show you the setup, the basic setup, just so you can follow. So we have our sphere and then our ground, right? Now on the sphere, I'm creating some arcs on the sphere itself. So I'm scattering some points and then scattering the same number of points, but in a different seed, creating an ID, merging them together, arcing between them. Obviously this goes through the sphere. So what I'm going to do is resample, add some noise, and then ray it onto the sphere, okay? And then because I've calculated my normals and I'm transferring my normals when I do the ray, I then have noise that I am pushing out along those normals. So now we have some kind of electricity on the sphere itself, right? So that's just for an extra kind of effect. But the main thing we're looking at here are these large arcs, and the large arcs are created in a similar way. We have some points scattered on the sphere, and we scatter the same number of points on the ground. Create an ID, merge them. Here I'm actually deleting a few of them because I want to sort of not have the same number of points as my original sphere. You could just scatter fewer points or whatever you want. So here I'm just choosing how many of them to keep or delete. We connect them, resample and noise, okay? And then just merge that all together, create some arcs, some like extra arcs that we've done before, and give it a color, right? So that's all very simple and the same as we've just discussed. But the big sort of difference is happening here when we're creating the noise of our arcs, okay? So you'll see the setup's very similar. We're obviously still, reseeding the noise sort of constantly as well as every 11 frames. But I have a very large amplitude here. So what's going to happen is these are going to sort of dip. If I switch this all off, you'll see that this is going to dip below the surface. If I just put on Ghost, you'll see that my arcs, my noise is making it dip above, which is great, but it also goes below, and that's not what I want. So we're going to use absolute. Remember we discussed on that graph how absolute can take everything that's below 0 and mirror it, but everything that's above 0 stays the same. And that's what we want to do here. If we clamped this to 0, right, then we'd end up with flat things along the surface, right? So if we just set a maximum here, so we set maximum to 0, remember, which was a way of setting a sort of a minimum, right? Then this is what we'd get. And that doesn't look very much like lightning at all, okay? It arcs up, which is fine, but lightning wouldn't necessarily lie flat along the ground. Yes, it sometimes does sort of skip along the ground and kind of run along it, but even when it's running along, it kind of arcs up a little bit and then touches, and then arcs up and touches. So this is not what we want. But if we absolute our Y value, what that's essentially doing, like let's just take one of these arcs, right? And you'll see here that what was below the surface, in fact, let's find a different frame where it's a little simpler. I'll reduce the number of arcs that we have. And so you can see here where something is dipping below the surface. Instead, we're just reversing what's below to go above. So now it arcs down, touches the ground, then arcs back up again, down, touches the ground, and up, right? So absolute gives us that really cool effect that looks, more like what we'd expect from arcs of lightning. So like here's another example of one. So you see, this whole arc is actually wanting to be below the ground, but we're just reversing that one. But then this one that goes above stays above. Okay, and so this is how we end up with our upper arcs. Now, I just want to show you, in case you don't know how to achieve that effect, it's the same setup as we had before. We've got our gradient, we've got our noise, we're adding that to our point position. But all I'm doing here is I'm getting the vector component 2. So I'm getting y. And then I'm absoluting just the y. And then I'm setting the second vector component. So I'm setting y to be equal to this value, which means that my x and z are left exactly the same, because we wouldn't want to do that to x or z, because this is a circle. We want it to arc in all directions, except on y, we want to make sure that it's only positive values and not negative. Okay, and that's all. So you see here how we have some very simple setups, but we've been able to kind of create these and control the way that electricity moves. Okay, so I hope this makes more sense and that you find it very useful.